to our session for today. Let us ask first the guidance of our Lord. Again, check ko lang, ako po ba ay narinig ng malakas at malinaw?
Opo, sir.
Ayan. Sige nga, will you lead the prayer, Carla?
Okay po, let us pray po. Thank you po, Lord, sa umagang ito ay sa tanghaling ito na pinagkaloob niyo po kami ng pagkakasama po ngayon sa lesson na ito. Nawa po i-bless niyo po ang bawat isa sa amin, pati po ang magtuturo sa amin. I-bless niyo po ang bawat isa. Nawa ibigyan niyo po kami ng karunungan at nawa makasagot kami sa mga topic na i-discuss sa inyo. Amen.
Ayan, okay. So, thank you. Again, good afternoon, BSED Math third year. Ayan. First of all pala, kung na-check nyo na yung Google Classroom nyo, may in-upload ako kaninang activity, problem set number 4. Di ba parang konti-konti lang na activity natin, ano? Problem set number 4 pa lang. So, problem set number 4, ang deadline noon ay sa Saturday. By the way, upon checking the Google Classroom, sa problem set number 3, about indirect proof, meron pang 6 na hindi nakaka-submit. Again, nakalagay sa instruction natin, late submission will not be accepted. No? Minove ko na yung ating ano niya na, minove ko na yun, in-adjust ko na yun. Kaya lang hanggang ngayon nakita ko, meron pa rin palang 6 na hindi nakaka-submit.
Sir, excuse me po. Sir, nag-upload po kasi ako nung time na yun, ayaw po talaga gumana. So, nag-PM po ako sa inyo, sinend ko po sa PM.
Okay. So, sige, check ko.
Sige po.
Ayan. Pero, so isa pa lang. So, 5 pa. 5 pa hindi nag-upload. Ayan. So, alam niyo sa akin, ayos lang naman sa akin, halimbawa kung ganyan nagkaka-problem. As long as sabihin niyo agad sa akin, maintindihan ko. Pero yung time na halimbawa, walang paramdam, tapos after 1 week, di pa rin pala nakaka-submit. So, what's the meaning of that? Ibig sabihin, binabaliwala niyo yung klase natin, binabaliwala niyo yung activity. No, sabi ko nga sa inyo, third year, every point counts dito sa college. That's why, napaka-importante ng bawat points kasi dyan binabase yung grades nyo. So wala akong magagawa kung yun lang ibibigay nyo sa akin, kung late submission, wala akong magagawa. As long as, ang mahalaga sa akin, yung iba, nagko-comply sa tamang panahon, sa tamang oras. Okay? So without further ado, let's start our class on abstract algebra. So, mag-start muna tayo by reviewing our lesson last time. Ano ba yun? Ito. Ayan. So, last meeting, we talk about mathematical proof by mathematical induction. Nakikita po ba yung screen ko?
Yes po.
Ayan, proof by mathematical induction. So, again, like what I said last time, no, we have 2 types of proof. We have well-ordered principles, saka principles of mathematical induction. Nag-focus lang tayo sa principles of mathematical inductions. We have 4 steps in proving statements and theorems under mathematical induction. Step 1 will be step 1 is the verification, where we will use or we will just change n to few or first few numbers, that is 1, 2, 3. Okay, ayan, n is equal to 1. Next, number 2, step 2, we have induction hypothesis. Sa induction hypothesis, ang ginagawa lang natin, we will assume, we will just create an assumption that the statement is true for all or for n is equal to k. Ayan, papalitan mo lang yung n is equal to k. And step 3, proof of the induction, where since we said that the assumption is true for n is equal to k, we need to secure that the statement is also true if n is equal to k plus 1. And number 4 is for the conclusion. Ayan. So yan lang po yung 4 na steps natin. So again, like what I said last time, mathematical induction is applicable to letter A, addition of suitable terms, letter B, addition and subtraction of suitable terms, and letter C, divisibility rules, and lastly, inequalities. So we already done with these 3, no? So tapos na tayo dito sa addition of suitable terms, addition and subtraction of suitable terms, and divisibility rules. So today, we will just give some examples on how to prove a statement, inequality statement using mathematical induction. Ayan. So yun lang gagawin natin ngayon. Saka magdadaglag lang tayo ng isa pang topic about congruences. Ayan. So these are some examples no last week or last time. Ito yung example natin. So I hope na nakuha niyo yung strategy dito and methods kung paano itong gagawin, kung paano ito i-accomplish. Ayan. By the way, di na ako nag-check ng attendance, so meron naman akong attendance tracker dito. Next. Ayan, ito examples. Ayan, okay na tayo dyan. Ayan, so ito yung example natin under ng addition of suitable terms. Tapos, ito naman yung example under ng divisibility rules. Ayan, wait lang, nasan ba yun? Ayan. Okay, ito yung divisibility rules. Then, ito naman yung example under ng, ito yung example under ng addition and subtraction of suitable terms. Ayan. So, ang kulang na lang natin ay yung example or discussion on how to prove in inequality statement using mathematical induction. Ayan. Okay. So this will be our first topic. Ayan. Ayan. So now, when we say inequality, ano ba yung mga inequalities na yun? Pag narinig yung inequalities, ano naiisip niyo? Anyone? Third year? Inequalities? Ano ba yun?
Ano po, sir? Try.
Oh yes, go.
Parang
Let's go.
greater than po, less than, ganun.
Very good. Ayan. When we say inequality, no, hindi siya equal, no? So, ang pumapasok doon yung mga symbol ng greater than, less than, greater than or equal, or less than or equal. So ngayon, let's talk about inequalities, proving inequality statement using mathematical induction. So we have example number 7, no, for mathematical induction. Show n, ayan. Okay. Show n is greater than 2 raised to n by mathematical induction. Pakialis na po ito. Wala yan dapat. Ayan, so we will just show n is greater than 2 raised to n by mathematical induction. So game. So sir, how are we going to prove this one? Same process lang po. We have 4 steps. We have step 1, verification, where we will just use few first numbers or few first terms to change n. So dito ang gagawin natin, we will change n be equal to 1. Ayan. So we will just change n be equal to 1. So gawin natin. By the way pala class, paki-turn on ng camera para nakikita ko kayo. Ayan. Okay. So we will just change n is equal to 1. So from here, we have n is less than 2 raised to n. So if we're going to change n by 1, this will become 1 is less than 2 raised to 1. So this will be, ayan, 1 is less than 2. Totoo po ba to that 1 is less than 2?
Opo.
Yes, that is true. So that means we can prove this statement using mathematical induction. Next, induction hypothesis. So we will just assume that the proposition is true for some positive integer n is equal to k. So we will just change n by k. So this will become k is less than 2 raised to k. Ayan. N is less than 2 raised to k. Ayan, ito na yun. So we'll just change n by k. So magiging k is less than 2 raised to k. Ngayon class, ang gagawin natin, itatabi nyo yung ating k is less than 2 raised to k kasi mamaya gagamitin natin yan. Kagaya lang ng ginagawa natin dati. No? Same process lang yan. Next, let's move on to step 3, that is proof of induction. So under proof by induction, sabi dyan, we shall show that whenever the proposition holds, then it also holds for the integer n is equal to k plus 1. So from, ulitin ko, kanina meron tayong k. We have k. Ano ba yan? Ay, ba't ganun? So we have k. Ulit. k is less than 2 raised to k. Ayan. So, ang gagawin lang natin ngayon, tatabi natin yan, yung ating step number 2. Mag-focus muna tayo kay n is equal to k plus 1. So, with this one, we will just change n be equal to k plus 1. That's why it will become k plus 1. Ayan, k plus 1 is less than 2 raised to k plus 1. Ayan, 2 raised to k plus 1. Okay, ngayon, anong gagawin natin ngayon? Ganito lang, class. Ayan. Makinig po muna. So, ang gagawin natin ngayon, gagamitin natin yung assumption natin sa step 2 that k is less than 2 raised to k. Ngayon, using our assumption in step number 2, no, gagalawin natin yan na kung saan kailangan maging kapareho sila nung nasa step 3 that k plus 1 is less than 2 raised to k plus 1. So, ang goal natin ay maging kagaya nito yung ating step 2. Nagigets po ba ako ng taong bayan? BSED Math here. Nagigets po ba ako?
Apo.
Ayan. So, since sabi natin whenever it is true for n is equal to k, anong gagawin natin ngayon? Gagamitin natin yung step 2. Kailangan maging kamukha siya nung nitong k plus 1 is less than 2 raised to k plus 1. Ngayon, anong gagawin natin? Kung titingnan natin class, no, yung nandito sa taas, ayan, ito ay k is less than 2 raised to k. So kung titingnan natin, okay. So ang unang gagawin dito, yung hypothesis natin sa step 2 that k is less than 2 raised to k, i-multiply natin siya kay 2. Ayan, i-multiply natin siya kay 2. Kasi nga dapat ang gagayahin natin yung nandini. So multiply mo siya kay 2, wait lang. Multiply the hypothesis by 2. So we will multiply the hypothesis. Ang hypothesis natin nasa number 2 ng hypothesis by 2. Ayan. So we will multiply the hypothesis by 2 and this will give us, ayan, this will give us, so 2k is less than 2 times 2 raised to k. Sir, alam ko magtatanong, sir, question, why do we need to multiply the hypothesis by 2? Bakit kailangan i-multiply yung hypothesis by 2? Plus, again, ito ang hypothesis natin, k is less than 2 raised to k. Ang inaabot natin o ini-aim natin ay magiging k plus 1 is less than 2 raised to k plus 1. Plus, tingnan yung exponent nito, 2 raised to k plus 1. So ito 2 raised to k lang. So what should we do? What should we do in order to have k plus 1 dito sa taas? So mag-multiply ka ng 2 dito. Nagets po ba ako? Di ba kasi, based nga sa ating pinag-aralan last time, no? Kapag pareho ng base, for example, we have x raised to y times x raised to 1, ay x raised to 2. Ano magiging sagot dito? Ano magiging sagot? X raised to?
Y plus 2.
Y plus 2. Di ba ganun yun? So dito, ganun lang din ang ginawa natin. Same sila ng base, nag-multiply lang tayo ng isa kasi k plus 1 ang hinahabol natin. Eh sir, paano kung ang nasa hypothesis natin ay nandito sa proof by induction is k is plus 2? At ang i-multiply mo, 2 raised to 2. Gets po ba ako? BSED Math third year? Nasusundan ako? Third year? Oh, nako. Yata nakakasunod. Third year, nasusundan po ba ako?
Okay.
Ayan. So, sir, bakit ganon? Bakit nag-multiply ako dito ng 2? Bakit sa kabila, nag-multiply din ako? Again, inequalities laws on equation. Sa equation, balance yan. Kailangan, pag gumalaw ka sa right side ng equation, gagalaw ka rin sa left side. Hindi pwede na pag gumalaw ka sa right side, hindi ka gagalaw sa left side. At kung ano yung item or kung anong value ang igagalaw mo sa right side, yun din ang igagalaw mo sa left side. That's why we multiply 2 on right side of the equation. Kailangan mag-multiply din tayo ng sa left side ng equation. Gets po ba ako? Ha? Nagets po ba ako?
Opo.
Okay. So in this part, no, yung right side na equation natin, we can say that itong right side na to, ito na ay is equal to 2 raised to k plus 1. Tama ba? Tama ba? So now, we don't have problem anymore in terms of the right side. Ang problema mo na lang ngayon, yung nasa left side. Kasi 2k to, ang ini-aim natin, maging k plus 1 yan. No? 2k nga yan. So, kailangan maging k plus 1 yan. Ngayon, ano gagawin natin? Ganito lang. So, okay na tayo dito sa part na to. Ang problema mo naman ngayon, si 2k. Ayan, si 2k ang problema natin. Di ba class, third year, di ba? 2k, so 2k is equal to k plus k. Tama ba? 2k is equal to k plus k. Ha? Tama ba yun? Eh di ba rin sabi kanina, or masasabi rin natin ngayon, that since k is greater than or equal to 1, then, no, lagi naman kasi ganyan yan, ang ilalagay natin sa k ay greater than or equal to 1 lang. No? So since k is greater than or equal to 1, then we can say that 2k is equal to k plus k. Ayan, 2k is equal to k plus k greater than or equal to k plus 1. Ayan, greater than or equal to k plus 1. Ano sinasabi dyan? Tama ba na yung value ni 2k ay greater than or equal to k plus 1 if k is greater than or equal to 1? Tama ba yung sinasabi? Class, no? Susunod pa rin tayo sa ating hypothesis or sa assumption na sinasabi natin k is greater than or equal to 1. Tama ba na yung 2k ay mas mataas or equal lang yung value kay k plus 1? Anyone? BSED Math third year. Tama ba? May possibility ba na mas magiging mababa yung ating 2k compare kay k plus 1? Sige nga, kayo nga class, isipin nyo nga. May possibility ba na mas magiging mababa yung k plus k na to o yung 2k compare dito kay k plus 1?
Wala po.
Wala. Very good. Kasi be secure that k is greater than or equal to 1. So try nga natin. What if sir k is equal to 1? So 1 plus 1 is equal to 2. No, tapos dito naman, yung k, papalito ko na 1. So 1 plus 1 is equal to 2. Anong sabi? 2k is greater than or equal to k plus 1. So pwede siya maging equal at mas mataas kay k plus 1. So ngayon, ano na ngayon? So since we already conclude that 2k is greater than or equal to k plus 1, thus, we have, ayan, pwede natin masabi that thus we have k plus 1, ayan, k plus 1 is less than or equal to the 2k, ayan, 2k, ano sabi sa kay 2k? Mas mataas yung value or equal lang yung value ni 2k kay k plus 1. Eh ano bang sabi sa hypothesis kanina? Ayan, wait lang. So ano bang sabi natin kanina? Sa statement na to kanina, na ang sabi natin, no? Ang sabi natin kanina that 2k is less than k 2 raised to k plus 1. Nasaan? So ang sabi natin kanina dito that 2k, no, 2k is less than 2k is less than 2 raised to k plus 1. Ito 'yon. Sabi natin yan sa hypothesis kanina. So ngayon, gagamitin mo lang yung equation na to saka yung equation na to. No? Class, kung titingnan mo yung dalawang equation na nilagyan ko ng rectangle, ano yung common sa kanila? Ano yung common? We have equation 1, ang sabi, 2k is less than, no? 2k is less than 2 raised to k plus 1. At dito naman, 2k is greater than k plus 1. Ano yung common sa kanila? Anong term ang common sa kanila?
2k po.
Yung 2k. So, ibig sabihin, yung dalawang equation natin, nag-limit sila kay 2k. Kasi ang sabi dito, no, 2k is less than to 2 raised to k plus 1. Dito naman, 2k is greater than or equal to k plus 1. That's why we can say, dito ngayon, kung isusulat natin siya in more simpler term, this will become 2k is greater than or equal to k plus 1, but less than to 2 raised to k plus 1. Ayan, but less than to 2 raised to k plus 1. Now, since ang sabi natin, nag-limit sila sa isang term, that is 2k. So masasabi natin ngayon, since ang 2k natin is less than to 2 raised to k plus 1 at greater than kay k plus 1, ibig sabihin, yung 2k na yan ay makikita mo sa gitna or sa pagitan ni k plus 1 at saka ni 2 raised to k plus 1. Tama po ba? Tama po ba? So eliminating 2k, this will become k, ayan, this will become k plus 1. K plus 1 is less than to 2 raised to k plus 1. And that will be our answer. Pareho na ba yan? O, ayan. So pareho siya. O, diba? Yung ito, palitan ko ng ano ulit, sorry. Okay. Ito, tama. Baka malito pala kayo. Ayan. Ayan. So, okay na. Nag-gets ba ako? Third year? Ha? Third year? O, nako. Galing-galingan nyo. Diyos ko sa midterm nyo, ganyan lang exam natin. Puro ganyan. O, yan lang na-discuss natin. Joke. Ayan lang. O, ano. Puro mathematical.
Question.
Oh, yes.
Sir, yung sa ano po, di ba yung multiply the hypothesis by 2 po? So, di ba nakalagay po doon 2 raised to k plus 1. So, paano po sir kapag po 3 raised to k plus 1? Sa 3 po siya i-multiply nun?
3. Sa 3. Kung ano yung base niya, yun ang gagamitin natin, kung ano yung base. Kasi we can multiply two exponential function na magkaiba yung base. So, kung ano lang yung base, doon tayo magbabase. Okay po ba?
Apa.
Ayan. So, question pa, wala na? Move tayo? Ha? Move pa tayo? Ayan. So, mag-move tayo. We have example number 8. Ayan, example number... sorry. So, nasa step 3 pa lang pala tayo. Siyempre, conclusion natin. Papahuli ba yung conclusion natin? So, our conclusion, kung ano lang yung conclusion na sinusulat natin dati, yun lang din yung sinusulat natin ngayon. No? So, ang conclusion natin sinusulat dati ay... Ayan. So, step 4, we have conclusion. So, for our conclusion, hence, the proposition, ayan, hence the proposition, okay, and hence, okay, gito na lang. Hence, if the proposition is true for n is equal to k, ayan, for n is equal to k, we have proved it to be true. Ayan, na-prove naman natin yan. We have proved it to be true for n is equal to k plus 1. But the proposition, so sa exam, dapat kabisado nyo yung conclusion na yan, ha? But the proposition holds for n is equal to k plus 1, n is equal to 1 is equal to k. Kasi nga, sinabi naman natin kanina yan. Hence, ayan, by step 3, sa proof of induction, by step 3, by step 3, it also holds for n is equal to k plus 1 is equal to 2. Ayan. Ayan. Being true O kaya class, kung kaya naman ng mahaba, pwede shortcut na lang. N is equal to 2 is equal to K. Ayan. Then, by step 3, it must also hold for N is equal to K plus 1 is equal to 3 and so on. So, kaya lang, ganun naman yan. Ayan. So, that is our example number 7. Ganun lang. Next, let's move on to example number 8. For our example number 8, we will show by mathematical induction that 2 raised to n minus 1 is less than or equal to n factorial. N factorial. Are you familiar with the term factorial?
Yes.
Opo.
Ano ibig sabihin ng factorial? For example, we have 3 factorial. Ano ibig sabihin nun?
3 times 2 times 1 po.
Okay, very good. No, multiply natin siya pababa mula sa number na yun. No? So that is factorial. So ngayon, ipoprove daw natin through mathematical induction that 2 raised to n minus 1, so that is exponential, is less than n factorial. So factorial term yan. So ngayon, step 1, ganun din naman. We have verification. We will just use few terms or few numbers to prove that this can be proved. To know that this statement can be proved using mathematical induction. We will just use n is equal to 1. So this will become 2 raised to 1 minus 1 is less than 1 factorial. And it will become 2 raised to 0. And 2 raised to 0 is less than 1 factorial. And the answer will become, wait lang, n factorial. O, tama. And the answer will become, yan. So, kung papansinin nyo, class, no? Ayan. Kung papansinin nyo, wait lang, 2 raised to 0 is equal to 1 factorial. Is equal to 1 factorial pala dito. Tama. Okay. So, greater than or equal pala siya. Sorry. Kaya pala kinakabahan ako. Greater than or equal. So, di ba 2 raised to 0 is 1? So, 1 is greater than or equal to 1 din. So, ibig sabihin, tama. Pwede siyang i-prove using mathematical induction. Now, let's move on to step 2. That is induction hypothesis. So, on this part, we will just assume that the proposition is true for some positive integer n is equal to k. So, this will become 2 raised to k minus 1 is less than or equal to k factorial. Ayan, k factorial. So again, ayan natin gagawin natin. No? So itabi natin yan, yung 2 raised to k minus 1 is less than k factorial. Itabi natin kasi mamaya, gagamitin natin yan. Ayan. So lagay ko lang dito. So we'll have 2 raised to k minus 1 is less than or equal to k factorial. Tama ba? Okay, tama. Okay. So now, let's move on to step number 3, proof by induction. In this part, we will show that whenever the proposition holds, then it also holds for the integer n is equal to k plus 1. So, papalitan lang natin yung n ng k plus 1. That's why it will become 2 raised to quantity k plus 1 minus 1 is less than or equal to k plus 1 factorial. Ayan, k plus 1 factorial. Now, gagawin natin, since sa proposition natin kanina, we said that, so since alam naman natin sa proposition, di ba ang sabi natin kanina, dito, whenever k is greater than or equal to 1. Whenever k is greater than or equal to 1. So ngayon, we can say that since 2, yung base natin ay 2, is less than or equal to k plus 1. Ayan. K plus 1. So, saan ginagalang yan? Dito yun. Ayan, k plus 1. Whenever, since 2 is less than or equal to k plus 1. So, tama ba yan? Kasi nga, class, k is greater than or equal to 1. 2 is, tama. K is greater than or equal to 1. So, possible, kung 1 to, 2 is equal to 2. Kung 2 yan, And then 2 is equal to, 2 is less than 3. Tama lang. Tama po ba? Nagigets ba ako? Third year? Nagigets po ba ako? Ha? Naku, wala na pa ako usap. BSED Math third year? Nagigets po ba ako? Ha? Wala ata ako. Narinig niyo ba ako?
Opo.
Nagigets niyo ako? Ha?
Yes po.
Oh, ayun, ganun lang, ano. Ayan, so sa base tayo nagbasa ngayon, ano, 2 is less than or equal to k plus 1. For k, sabi nga natin, for k is greater than or equal to 1. Then, so ngayon, meron tayong dalawang equation. So then, if we're going to combine, if we're going to combine this with the hypothesis, ano ba yung hypothesis natin? Ito, the 2 raised to k minus 1 is less than or equal to k factorial with the hypothesis, no? Ayan, pag pinag-combine daw natin yung dalawa na yan, ayan, we will have, so pag pinagsama natin, no? So, isa natin, ang ating hypothesis ay 2 raised to k, dito ko na isulat, 2 raised to k minus 1, ayan, 2 raised to k minus 1 is less than or equal to k. By the way, so ano bang ginagawa natin? Again, class, no? Ang ginagamit natin yung ating proposition sa step 2 at ang goal natin ay maging kagaya niyan ito. Dapat maging magkamukha sila. So, sir, anong ginagawa natin ngayon? Pagsasamahin lang natin yung ating hypothesis that is nasa step 2, yung 2 raised to k minus 1 is less than or equal to k factorial, no? K factorial, isasama natin yan dito sa ating hypothesis ngayon na sinasabi natin that 2 is less than or equal to k plus 1. Ayan. For k is greater than or equal to 1. Ayan. So ngayon, ano gagawin natin? Ayan, dapat dito to. So thus, with 2, pag pinag-combine natin yan, thus with 2 inequalities, pag sinabing combine, pagsasamahin. Pag pinagsama, no? Pag pinagsama, pinag-a-add. We will obtain, ano yung ma-obtain natin? We will obtain that 2 raised to k, pagsamahin natin, class. So pag pinagsama natin yan, this will become 2 raised to k na lang yan kasi yung nandito, magiging ano na lang to, no? 2 raised to k. Ayan. So magiging 2 raised to k na lang is less than or equal to k factorial, ayan, k factorial times k plus 1. Ayan. Dito pala pinag-multiply pala natin, pinag-multiply natin. So dahan-dahanin ko nga, baka malito kayo. Ayan, dahan-dahanin natin. So paano yon? We have first equation, ito yon, and equation 2, yung ating hypothesis. So pinag-multiply natin, so magiging 2 raised to k minus 1, ayan, 2 raised to k minus 1, saka yung 2 times 2, ito yon. Pareho naman silang less than or equal, pagsamahin natin, k factorial times k plus 1. Ayan. So next, bali ito, pag sinimplify mo to, magiging 2 raised to k minus 1 plus 1 is less than or equal to k factorial times k plus 1. Ngayon, ito tayo. So pag sinimplify mo yan, it will become 2 raised to k na lang. Kasi negative 1 plus 1 is 0. That's why magiging 2 raised to k na lang is less than or equal to k factorial quantity k plus 1. So ngayon, if we're going to simplify this term, no? Kung isa-simplify natin yung term na to, di ba yung k factorial, same lang din naman siya nung atin na nasa k, doon sa k plus 1. We can say that 2k or 2 raised to k is less than or equal to
K plus 1 factorial lang.
factorial. Galing. K plus 1 factorial na. So that's the answer. That is our answer. Same ba siya? Yes. Same siya naman dito. The 2 raised to k plus 1 minus 1 is less than or equal to k plus 1 factorial. Ayan. Nasundan po ba ako? BSED Math 3rd year.
Opo.
Ayan. Ganun lang yun. Diba? So ngayon, that is our lesson for mathematical induction. I hope nakakuha niyo yung step-by-step process, yung strategy. Halimbawa, wala na ako, kayo na lang kung paano yung sasagutan. Lalo na sa midterm examination natin. So, puro mathematical induction yun. Maghanda-handa. BSED Math 3rd year. So ngayon, for your practice din, nagbigay na ako ng 10 items, no? Nasasagutan nyo sa ating Google Classroom. Madadali lang naman yun. Wala akong ganong binigay about inequalities. Halos lahat lang ng yon ay nanggaling sa addition and subtraction of suitable terms. So madali lang yun. Kayang-kaya nyo yun. Saka divisibility rules lang. Any questions in mathematical induction, 3rd year? Any clarifications, violent reaction? 3rd year?
Wala naman.
Ayan. Sherilyn, may question ka ba, Sherilyn?
Wala naman po, sir.
How about you, Stephanie? Stephanie?
Wala din po, sir.
Okay. 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 So now, let's move on to our next lesson. Diba? Lagarin tayo ngayon hanggang Biyernes para marami kong maitanong sa midterm. Ayan. Ayan. Tatapusin natin yan hanggang bago mag-midterm. So, game. So, may klase tayo ng Friday. Tapos, ang kasunod doon, magkaklase ulit tayo ng Friday. Tapos, midterm din. Diba? Ay! Wala pa ng pasok next Friday, no?
Wala
Tama ba?
po, sir. Kala ko hindi po mag-class ng Biyernes Santo.
Yun, tama. So, dapat mag-move tayo ng Monday. No. I-move natin ng Monday, 12 to 3. Ayos lang ba yun, Class Mayor? 12 to 3 Monday?
Sir, nasa biyahe po ako, Baguio.
Uy, sana all. Ayan. So, yes. Yes, sa Monday. O kaya, Saturday. Pag nag-klase tayo di ba, ayos na, nagkari talaga. Wednesday, Friday, to Saturday. Pag nag-klase tayo
Sabado
ng
de Gloria, sir.
Hindi, Saturday this week. Saturday this week. Ayaw nyo? O ano? So, ayan. So, it's either, nga pala. Pati pala yung sa iba. So, it's either Monday, Tuesday, Wednesday. Pumili kayo. Saan kayo maluwag?
Tuesday po.
Tuesday, 12 to 3? Okay. So, we will have class on Tuesday, Tuesday, 12 to 3. Kapalit nung Friday natin. Diba? Para marami kong maitanong sa midterm. Lalagariin natin lahat yan. So, next, let's move on naman sa ating next lesson. Diba? For our next lesson, let's talk about modulo. Familiar po ba sa modulo?
Opo.
Uy, sana all familiar sa modulo. Okay. So, let's talk about congruences. Ayan. So, I know that most of you are, when we say congruences, ang naiisip niyo agad ay triangle. Kasi kadalasan ginagamit sa geometry, triangle, congruences. But this time, we will talk about congruences in terms of modular arithmetic. Ayan. In terms of modular arithmetic. So, when we say modulo, ano ba yung modulo? Di ba sinabi ko na sa inyo ba yun o sa ibang klase? When we say modulo, ang isipin nyo lang, parang clock. Di ba kasi yung clock, umiikot yan, kaya lang may certain point lang yan na kung saan babalik yan ulit sa pinaka-umpisa. Para siyang cycle. Pag na-reach niya yung point niya, babalik siya sa umpisa. Tama po ba? Yung clock kasi, pag na-reach niya yung 12, tutuloy ba ng 13, 14 yun? Di ba hindi naman? Tama po ba? Di ba? Ang mangyayari sa clock, babalik na ulit siya ng 1, 2, 3, hanggang makarating ulit ng 12, babalik ulit. Di ba? Parang lang siyang cycle. So that is modular arithmetic. Parang ganun lang din yun. So ngayon, ano ba yung pinag-uusapan in terms of modular arithmetic or congruences in terms of modulo? So very often, mathematicians invent notation for certain terms. For instance, in algebra, we use logarithm. So bakit pa kailangan pa ng logarithm sa algebra? May exponential naman, di ba? So bakit kailangan pa tinatransform yung exponential sa logarithm? Kasi nga daw, ang mathematicians, kadalasan, ang gumagawa sila ng mga terms kapag in terms of mathematics. That's why nagkaroon ng logarithm kahit na meron namang exponential. So in higher mathematics like abstract algebra, we often use the notation. Ang notation na ginagamit natin sa abstract algebra, ganito, yung notation na to. Para siyang equal, kaya lang ito, tatlong line. Yan, tatlong line na ganyan. So we often use this symbol for remainder or congruences. No? It determines the remainder kapag ganire. No? We use the symbol for remainder. For example, we have the statement 9. Ayan, for example, we have 9 is, for example, we have 9 and 23. Ayan, 9 and 23. Ayan, 9 and 23. Now, kung we have 9 and 23, this leave a remainder. This leave a remainder on division by 7. So, ano sinasabi dyan? Sir, ibig sabihin ba yan, kapag yung dalawa na yun ay sinulat ko, pareho sila ng remainder? Yes. Kung i-divide mo yung 9, kung i-divide mo yung 7 kay 9, ano yung remainder mo? The remainder is
2.
2. Tama ba? So, ito rin naman, kapag i-divide ko yung 7 kay 23, what will be the remainder?
2 din po.
2 din. So class, are you familiar with, di ba na-discuss itong modulo? Saan yan discuss to? Sa number theory ba? Sa number theory? Ha?
Opo.
So, ibig sabihin, di na ako gano'ng mahihirapan kasi familiar na kayo?
Nahihirapan pa din po.
Ano ba yan? Paano? Na-discuss ba sa inyo kung paano kunin yung ano? Halimbawa, we have 7 raised to 1028. Ano yung last number nun? Na-discuss ba sa inyo yun?
Hindi po.
So halimbawa, we have we have 7 raised to 285 divided by 26. Ano remainder nun? Naturo ba sa inyo yun? Talaga? Dapat sa number theory yun, pati yung mga Chinese remainder theorem, sila Fermat's theorem. Ayan. Pero sana maabutan natin yung mga ganun. Madaanan natin yung mga ganun. Okay, so ngayon, ganyan lang din yun. So ngayon, paano natin gagamitin yung symbol na to? Using the statement above. So it can be written as 9 is congruent to 23 modulo 7. Ayan, modulo 7. So ngayon dito class, no? 9 is congruent to 23 modulo 7. Sorry. Di ba pa? Mamaya pa. So modulo 7. Ang ibig sabihin niyang class, congruent yung 9 sa yung 23. Bakit sir naging congruent? Kasi kapag dinivide ko yung parehong number na yan sa 7, pareho yung kanilang remainder na 2. Gets po ba ako? Ha? Nagigets po ba ako? So ngayon, ang ginagamit nating symbol dito ay itong tatlong linya na to. So ngayon sir, paano mangyayari yan? Paano gagamitin yan ganito? For example, we have 26 is congruent to 3, is congruent to 5 modulo 7. So this is the general symbol or general terms pagdating kay modulo or kay modular instruction. So anong ibig sabihin yan? Ganito lang yung ibig sabihin yan. Ang sinasabi dito, kapag yung 7, ito yun, ay dinivide ko sa 26, ang remainder niya ay 5. Nagigets ako? Ganun po yung ibig sabihin yan. Kapag yung 7, dinivide ko kay 26, ang remainder niya ay 5. So in definition, no? So in definition, ayan, definition number 1, if m is a positive integer and M divides A minus B, then we say that A is congruent to modulo M, and the symbol, ito yon. A is congruent to B modulo M. Kagaya ng sinabi ko, kapag dinivide ko yung ating M kay A, so magiging M over A, ang magiging remainder mo daw, o M over A, remainder ay yung B. Ganun lang yan. M over A, ang remainder natin ay B. If A is not congruent to B, modulo M, we write A is not equal to B modulo M. So ano sinasabi sa definition number 1? How are we going to know if the given is congruent or not? So ang sabi dito, M divides A minus B. So we have A is congruent to B modulo M. So ang dapat lang mangyayari, ang magiging divisible yan. For example, we have 26 is congruent to 5 modulo 7. Kung itatest mo kung congruent ba yan o hindi, so sabi, M divides A minus B. So dito, ano yung magiging M natin? Given this 26 is congruent to 5 modulo 7, ano yung magiging M natin?
7 po.
7. Ano yung A?
26.
26. Ano yung B?
5.
5. So sabi natin, M divides A minus B. So ang M dapat natin, itong 7, is divisible yan kay A minus B. Ano ba yung A minus B? Ang A natin ay 26 minus ang B natin ay 5. So tama ba that 7 is divisible by 21?
Opo.
Tama ba? Yes. O, di ba? So, kapag ganito ang nangyari, congruent yan. Nagigets po ba ako, BSED Math third year?
Opo.
So, saan natin binase yung ginawa natin ito? It is based on the definition number 1 saying that if M is a positive integer and M divides A minus B, then we say that A is congruent to modulo M. In symbol, A is congruent to B modulo M. By the way pala, sabi dyan, M is a positive integer. Dapat ang M natin ay positive integer lagi. So, paano naman kapag hindi sila equal o hindi divisible? For example, we have 12. Buhay ko lang to. For example, we have 12 is congruent to 5 modulo 4. Ayan. So, paano itatest yan? Itatest mo yan using M divides A minus B. So, dito, ang M natin ay 4 divides A minus B ay 12 minus 5. So, tama ba that 12 ay 4 is divisible by 7?
Hindi po.
Hindi. Therefore, this is not congruent. Nagets po ba ako third year, math major?
Yes po.
Opo.
Ganun lang yan. Next. Ayan. Okay, let us solve some examples. Ayan. So for some examples, no, so the negative integers can also be applied in the use of congruence. Ayan, yung mga negative integers pwede rin gamitin. For example, we have number 1, negative 1 is congruent to 6 modulo 7. Ayan. So ito ba ay congruent? Tanong ko sa inyo, congruent ba to? Ha? Congruent ba to? Math major?
Opo.
Ayan, bakit naging congruent? Kasi nga, since
Minus tas negative 1 po. Negative times negative magiging positive po kaya plus 1.
Okay. Okay, very good. Since, okay, pero unahin natin si A, no? Ang A kasi natin dito ay negative 1. So, since negative 1 minus 6 is divisible by 7. Siya ngayon ay congruent. Number 2, we have negative 2 is congruent to 5 modulo 7. So ito ba ay congruent? Yes, because since negative 2 minus 5 is divisible by 7. Tama ba? Divisible ba yung 7?
Opo.
O, diba? Next, number 3. We have negative 1 is congruent to 10 modulo 11. Plus, ano ba pinapakita ko dito? Baka kasi isipin nyo, sir, tama ba na puro positive lang nandito sa right side? Pwede rin siya sa negative integer. Kagaya ito, nakikita natin na congruent din naman siya. Kasi nga ito ay since ayan, negative 1 minus 10 is divisible by 11. Diba? So, congruent siya. It's divisible by 11. Isa pa, we have number 4. We have negative 7 is congruent to 5 modulo 3. O, since negative 7 minus 5 is divisible by 3. So therefore, sila pa rin ay congruent. Gets po ba ako ng taong bayan? Third year, math
Apo.
majors? Ayan, so ganun lang yun. Madali lang yung malaman, ano? Madali lang makabasada yun. So now, the following are equivalent to each other and may be used interchangeably. So ibig sabihin, pare-pareho lang sila ng value. Equivalent nga, no? Pare-pareho lang sila ng value. Ang magkakaiba lang, naiiba lang sila sa kanilang notation. We have number 1, kagaya ng ginagawa natin kanina, we have A is congruent to B modulo M. Again, class, kung ito yung ating symbol or yung ating notation, nasaan dyan yung remainder?
Yung B po.
Very good. Ayun yung B. No, next. Ayan, kamukha lang yan ng ating number 2 which is M divides A minus B. Same lang sila ng value niya. M divides A minus B. At lastly, we have A is equal to B plus MK for some integer K. Ayan. Ayan, for some integer K. A is equal to B plus MK for some integer K. So dito naman class, kung papansinin nyo, no? Since ito yung ating dinidivide sa isang whole number, i-multiply mo lang siya sa kanyang, ito yung K natin is some integer. Hindi natin siya alam, pero kahit anong integer yan pwede. Or sa ilang integer pwede yan, yung K. So dapat na magiging sagot dyan ay yung A. So dapat magiging A is equal to A yan. So that means, no? That means, if our A is 25 or our A is 12, oh sorry, wait lang, gawin natin. For example, we have A, we have 26 is congruent to 2, modulo modulo 12. Ayan. So kung susundin natin to, no? Kung susundin natin yan, so we have A that is 26, dapat is equal to B. Ang B natin ay 2 plus MK. So let's say that K is, ang M natin ay 12, let's say that K is 2. Ayan, K is 2. So tama ba that this will become 26 is equal to 26? Tama ba yan? Ha? Tama po ba yan?
Opo.
So, ang sinasabi natin, same lang sila ng value, ng notation. Ay same lang sila, equivalent lang sila, ang pagkakaiba lang ay yung notation. Tandaan niyo yan, tatlo na yan. We have A is congruent to B modulo M, and M divides A minus B, and lastly, we have A is equal to B plus MK for some integer K. Now, we will give the first theorem related to division algorithm. So, other examples daw. Other examples ng congruence, we have letter A, 7 is congruent to 25, no? 7 is congruent to 25 modulo 6. Ayan. Modulo 6. So, ay sir, bakit ganyan? Kala ko ba sir, ito yung ating remainder? Diba? Kala ko ba sir, ito yung remainder? Ba't parang mas mataas pa yung remainder natin ngayon sa ating value? So, dito, congruent pa rin yan kasi nga, since, ito pa rin tayo magbabasa sa rule natin, 7 minus 25 is divisible pa rin yan kay 6 is divisible by 6. O, isa pa. We have letter B, we have 31 modulo 49, ay 31 is congruent to 49 modulo 9. Ayan pa rin ay congruent since 31 minus 49, wait lang. 31 minus 14, tama lang pala, 18 pala, is divisible pa rin kay 9.
9.
Ayan, divisible pa rin kay 9. O, isa na lang, we have letter C. We have 51 is congruent to 84 modulo, modulo 11. Since 51 minus 84 is divisible pa rin yan divisible kay 11. Kasi 51 minus 84 is 33. 33 is divisible by 11. So, yun po yung ating other examples on congruence. Now, let's move on to different theorems related to congruence. So, we have theorem number 1, sabi dyan, every integer is congruent modulo m to exactly one of the integers 0, 1, 2, up to m minus 1. Ang sinasabi, every integer daw ay congruent, no, sa ating modulo m to exactly one of the integers 0, 1, 2, up to m minus 1. So, paano natin ipoprove yung ating theorem na to? So, lagyan natin yung proof. So, dito, in order to prove this one, we will just let A be an element of Z. Ibig sabihin ng Z ay integers. Then by dividing A, so naman ginagawa natin dito sa remainder na to, then dividing A by B, dividing A by M, so ibig sabihin, i-divide mo yung A kay M, no? So dividing A by M, i-divide mo yung M kay A, ayan, dividing A by M, we will have A is equal to MQ plus R. Ayan, MQ plus R, where R is less than or equal to 0, but is greater than or equal to 0, but less than M. Ayan. Or A minus R is equal to MQ. Same pa rin naman yan. No? Nilipat lang natin si R dun sa kabila. So, A minus R is equal to MQ. So, since M divides, sabi natin ganun sa rule, M divides A minus R, then A is congruent, and A is congruent to R modulo M. Where R is greater than 0 or greater than or equal to 0 but less than M. Thus, R is exactly one of the integers 0, 1, 2 up to M minus 1. Ayan, M minus 1. So, ano sinasabi dyan, class? No? Most of the time daw, ang lumalabas na remainder ay ito lang mga integers na to. 0, 1, 2, up to M minus 1. Most of the time. No? 0, 1, 2, M minus 1. So, di ba halimbawa, we have 24 divide, kapag yung 24, dinivide natin kay 6. 24 divided by 11. Ayan. 24 divided by 11. Class, kung isusulat ko to into notation ng congruences, this will become, paano? Sige nga. Paano ito isusulat? This will become 24 is congruent to, ano ba yung remainder kapag dinivide ko 11 kay 24? Ano ba yung remainder?
2 po.
2. 24 is congruent to 2 modulo 11. So ito yung sinasabi dito. Yung kadalasan na nagiging remainder ay 0 to M minus 1. So laging M minus 1 lang. So 0 ang remainder kapag walang remainder. So dito ay 2. Nag-gets po ba ako, BSED Math third year? Ha? BSED Math third year, nag-gets po ba ako? Ayan. So next, sa remainder natin, no, sa remainder, we call the remainder R as the least residue of A. Ayan. So the word residue is merely technical term which has the same sense as the remainder. So pinapalitan daw natin minsan ang pangalan remainder as least residue. From the word least, ibig sabihin, ito na yung pinakamababang remainder, least positive remainder. Ayan. So the word residue is merely technical term which has the same sense as the remainder. The set of integer s is equal to 0, 1, 2 up to m minus 1 is called the least residue system. Ayan. System modulo pala. Ayan. So bilugan ko lang. So again, no, we call the remainder R as the least residue of A. The word residue is merely technical with the same sense of the remainder. Yung set na to, that is 0, 1, 2 up to m minus 1, ang set na yan, ang tawag dyan ay least residue system modulo m. So sila, yung mga possible na maging value natin para kay remainder. If A is an element of C and A is congruent to R modulo m, then R is one of the integers in the set S. Ayan, ito nga yun, remainder. Gaya ng sinasabi ko, kung ang A natin ay integer, no? At ang A is congruent to R modulo M, yung remainder natin, possible siya na nasa loob ng list na to, ng list residue system modulo M. Nagigets po ba ako ng taong bayan? Third year? Math major, nagigets po ba ako? Ha? Oh, math major, naku, nakatulog na ata. Narinig ba ako? Na? Third year? Ayan. Ako, passive tayo. Ayoko ng passive. Diba? Siguro naman, alam niyo may passive learner sa active learner. Siyempre, alam niyo yun, di ba? Ayoko ng passive. Gusto ko may kausap ako mamaya, naka-off na pala yun, namatay na pala yung Google, magsalita pa ako ng salita dito, di ba? Ayan. So, that is congruences. So, huwag kayong mag-alala, huwag mag-alala. Wala pa tayong sinosolve. Definition pa lang to, no? Theorem pa lang to. Wala pa tayong sinosolve, ha? Ayan. So, yun yung example niya, no? So, ngayon, for example dito, ay, naku. Ayan. So, for example, by the way pala, no, again, remainder, tapos Z. So, for instance, no, the least residue of 38, no, for example, the least residue, ibig sabihin yung remainder, no, the least residue of 38, the least residue of 38 in modulo 3, 4, 5, and ayan. So the least residue of 38 in modulo 3, 4, 5 and ayan, 3, 4, and 5. Ano? Sige nga class, BSED Math third year. Ano yung magiging least residue ng 38 in modulo 3? Anyone? So what will be the least residue of 38? So 38 is congruent to blank modulo 2 po. Ito ay 2. Very good. Very good. 2. Sir, bakit naging ganun? Bakit naging 2? Ayan. Bakit naging 2 yung least residue nun? Kasi nga, class, kung titingnan natin, no, ito kasi, yung modulo 3, pag dinivide ko yan, yung 3, pag dinivide ko sa 38, magiging 12. Tama ba? And 12 times is 36. May tirang 2. So, kung isusulat mo yan, it will become 38 is congruent to 2 modulo 3. Eh, paano naman yung 38, yung least residue ng 38, that is congruent to blank modulo 4. Ano yung magiging least residue ng 38 modulo 4? Anyone? Third year? What is the least residue of 38 in modulo 4? 2 pa din. Very good. 2 pa din. Kasi nga, 38 divided by 4 is 9, remainder 2. O class, napapansin nyo ba yung remainder ay yung nandito kay B. Lastly, we have 38 is congruent to blank modulo 5. Ano ilalagay ko dito?
3 po.
3 po.
Ayan, galing. Kasi nga, hanggang 35 lang yun. So that is matitira na 3. That is our least residue or what we called remainder. Ayan. By the way pala, no, dito class, as you can see, no, R is equal to 2 that is less than 3. Ayan. Mas mababa yung 2. Siyempre, mas mababa yung remainder compared do sa pinag-divide natin. So dito naman, R is equal to 2 less than 4 at R is equal to 3 less than 5. Gets po ba ako ng taong bayan? BSED math third year? So, ganun lang yan. So pinapamiliarize ko na kayo sa notation, ha? So for the next theorem, we will provide a sufficient and necessary condition for the validity of congruence. So let's talk about the theorem number 2. The integers a and b leave the same remainder on division by m if and only if a is congruent to b modulo m. Ano sinasabi? Yung integers daw a and b will leave the same remainder on division by m if a is congruent to b modulo m. So same daw ang magiging remainder. So paano yun? Ayan. So sa theorem number 2, that the integers a and b leave the same remainder on division by m if and only if a is congruent to b modulo m, i-prove muna natin. So proof natin. So proof. Ayan. So for the proof, we will suppose that a and b have the same remainder. Sabi nga dyan sa theorem, have the same remainder. Ibig sabihin, pareho sila ng remainder, kagaya na ginawa natin sa, sa 9 and 23 kanina, no? Parehong 2 yung nila, 9 and 23 modulo 7, parehong 2 yung kanilang remainder. So suppose A and B have the same remainder upon division by M, upon division by M, so example, no, let us have some example. A is congruent to MQ1, MQ sub 1 plus R. That is the remainder, no? And B is equal to MQ sub 2 plus R. Ayan. So kasi nga, sabi, we're supposing that A and B have the same remainder. Pareho sila ng remainder. That's why, yung A natin, para makuha yun, is congruent to MQ plus 1, MQ sub 1 plus R. Yung B naman is MQ sub 2 plus R. Kasi nga, same sila ng remainder. Where R is greater than 0, greater or equal to 0, but less than M. But less than M. So, ano mangyayari ngayon, class? And Q pala, and Q sub 1, Q sub 2 is an element of Z or integers. It's an element of the integers. So then, kung kukunin ko yung A minus B niyan, no? Ano magiging sagot? Pag kinuha ko A minus B, this will become A minus B, ito ko na ilagay. So then A minus B is equal to, so pag sasubtrakin ko yan, this will become M Q sub 1 minus M Q sub 2 plus R minus R. And this will become, R minus R is 0, cancel na yan. M quantity K sub 1 minus Q sub 1 minus Q sub 2. So, ngayon class, napapansin natin, no? Sabi dyan, A minus B is equal to M quantity Q sub 1 minus Q sub 2. Since Q sub 1 minus Q sub 2, kasi nga ang sabi natin, lahat naman sila ay element ng integers or Z, no? Then, we can say that M divides A minus R. Then we can say that A M divides A minus R, or in modular notation, or A is A is congruent to R modulo M. Ayan, modulo M if A and B leave the same remainder upon division by M. So that means, no, totoo na na-proof natin that the integers A and B leave the same remainder on division by M if A is congruent to B modulo M. Now, sa definition ng congruence, congruence is a general form of equality. Many properties of equality are being carried over to congruences. So, general form daw siya ng equality. Kumbaga kasi pag sinabing equal kasi, same ng value. Same si A at same si B. Ano naman pinagkaiba ni congruence? Si congruence naman, kumbaga general form siya ng equality. Ang pagkakaiba lang, hindi kagaya ng strict kasi sa equal. So dito, binibitbit lang niya yung mga properties of equality, that is, letter A, reflexive property, in congruence, saying that A is congruent to A modulo M, and symmetric property, where if A is congruent to B modulo M, then B is congruent to A modulo M. Lastly, we have transitive property, if A is congruent to B modulo M, and B is congruent to C modulo M, then A is congruent to C modulo M. So, ano pinagkaiba? Pareho lang po sila ito. B modulo M, so ito naman B. So, naging A is congruent to C modulo M. So, that is our congruence. And that is our congruence. So, now let's move on to the theorem number 3. So, theorem number 3 says that congruence of integers modulo M is an equivalence relation. Ayan. So, equivalence relation. So, pareho lang daw. So, ngayon, paano ipoproof to? No? I-proof natin. So, proof ng ating theorem number 3. Proof. Ayan. So, proof niyan, number 1, for the proof niyan, the relation congruence is, and the relation congruence is reflexive, since, ayan, since, bakit siya naging reflexive? Since M divides A minus B. Ayan. M divides A minus A. So, tama ba? Divisible yung M kapag yung ating remainder ay 0. Yes, divisible yun. Or, divisible naman yung M o yung ating 0 divided by 7. Divisible pa rin naman yun. Kaya siya ay naging reflexive kasi nga sa relation ng congruence, yung ating M divides A minus A. Kaya siya reflexive. Next. Ayan, M divides A minus A. Or, A is congruent to, A modulo M. Same pa rin naman yan. Same lang yan ito. Magkaiba lang sila ng notation. Next, for number 2. So for number 2, if A is congruent to B, modulo M, if A is congruent to B modulo M, then we can say that M divides negative A, quantity A minus B. Okay, negative A, quantity A minus B. Okay, negative A, quantity A minus B. It follows that B is congruent to A modulo M. Congruent to A modulo M. Ayan. So, kaya siya ay naging symmetric, and so the relation is symmetric. Ayan, symmetric. Next, for number 3, we have if M divides A minus B and M divides B minus C. Ayan. Sorry. M divides A minus C. Sorry. A minus C. Thus, we can say, thus, A is congruent to C modulo M. Pakitandaan po yung mga theorems na to. And so the relation is and so the relation is transitive. Ayan, pwede mo silang pagpalit-palitin. Same pa rin ang magiging value nila. Okay? So that is the proof for theorem number 3. So next, the preceding theorem that the set of integer is divided into mutually exclusive cases or classes. These classes are called residue or equivalent classes. Kung nakita nyo, no, or mamaya makikita nyo, paghahati-hatiin natin, no, yung exclusive, paghahati-hatiin natin yung mga magiging remainder sa mutually exclusive classes. So ang tawag po sa classes na gagawin natin mamaya ay residue or equivalent. Residue or equivalence classes. Residue or equivalence classes, and that by this residue system, 0, 1, up to m-1 are representative of these classes. So representative lang daw ng classes na yon, yung 0, 1, up to n-1. Since exactly every integer is congruent to one of them, to one of the m least residue modulo m, since one of the integers 0 and 1 up to m-1 belongs to one equivalence class, we shall call these classes, ito na pala yun. Ayan. So every integer is congruent to one of the m, least residue modulo m, since exactly one of the integers 0, 1 up to m-1 belongs to one equivalence class, we shall these classes 0 up to 0 sub m, classes of 1 sub m, and classes of m-1 sub m, the residue classes modulo m are. Ayan. So ngayon, kukunin natin yung classes na yan. So paano ba yung magiging classes ng mga yan? Ganito. So unang gagawin, so kunin muna natin yung residue classes ng S, classes of 0. Ayan. Residue classes of 0. Ayan. So ang classes niyan ay possible na mk, where m is the, kung ano yung dinidivide mo sa value, mk, such that k is an element of z, and k is an element of z, that is also equal to the classes of 0 sub m. And the classes of 0 sub m. So kunin naman yung classes of 1. So dito ang rule dito, mk, or sorry, mk plus 1, kapag 1 naman, mk plus 1, such that k is an element of z. So ito, ang equal nito ay classes of 1 sub m. Nagigets po ba ako, math major? Ha? Eh mamaya, magbibigyan ko ng example dito. Next, sa S sub 2 naman, or sa classes of 2, this will become mk plus 2 naman, syempre. mk plus 2, such that k is an element of z. That is equal to classes of 2 sub m. So sa classes of 3 naman, we will have mk plus 3, syempre, such that k is an element of z. That is equal to classes of 3 sub m. Ayan. So, for more concrete example, no, sa concrete example niya, for example, we have classes of 0 sub 4. Sir, ano bang ibig sabihin ng classes of 0 na yan? Dapat po, sa loob ng classes na yan, 0, lalabas sa ating system ang 0. So, paano yun? So, this will be 4k, di ba ang sabi kayo na mk. Ano ba yung ating m? 4. Kaya ito ay magiging 4k such that, so, class, kung papansin ng class dito, magkakaroon tayo na tawag na arithmetic progression. Kasi meron tayong makikitang pattern. So, ano yung magiging pattern natin? Lahat yan ay may 4. So, padagdag lang tayo na padagdag sa 4. Kaya dito, ito ay magiging from negative infinity up to negative 4 Dapat lumabas si 0, kaya ito na si 0, 4, 8, up to positive infinity. So we can say ngayon that the classes of 0, sub 4, or modulo 4 is equal to 4k such that 4, 0, 4, 8 up to positive infinity. Ayan. Yun yung ating mga values ng ating such that z pala, such that ayan, sorry. Dito pala ay is equal to 4k, okay, and is equal to 4k such that k is equal to 4k such that k is an element of z, and that is equal to 4, 0, negative 4, 0, 8, and etc. Next, gawin naman natin sa classes of 1, modulo 4. Dapat naman dito, lalabas si 1. So this will become 4k plus 1. Kasi nga, mk plus 1 sabi niya. So 4k plus 1 such that k is an element of z, we're equal to, dapat lalabas si 1 dyan. So from infinity, so magiging negative 3. Ayan, negative 3. 1, 5, 9 up to positive infinity. Ganun lang yun. Next, ito naman, dapat lalabas si 2. Sub 4. So magiging infinity or 4k plus 2, katatagal lang 2, such that k is an element of z, that is equal to, dapat lumabas si 2 dyan, kaya ito ay magiging negative 2. Sorry, dapat mula dito. Magiging negative 2. 2, 6, and etc. So sa 3, ganun din naman sa 3, magiging negative 4, negative 1, negative 1, 3, 7, 11, and so on. Nagets po ba ako, third year? Nagets po ba ako, BSED Math or Math Major? Nagets ako? Ha? Math Major? Okay. So that is our theorem number 4. Now, para saan ba yung mga theorem na yan? Pakitandaan nyo yung mga theorem na yan kasi later on, we will use those theorem in order for us to solve for the remainder and the unit digit. Ayan. So note that any integer in a given residue class is congruent modulo m to any other integer in that class and not congruent to any integer in any other class. Next, let's move on to theorem number. Ayan, meron pa pala. Sabi dyan, the next theorem shows addition, subtraction, multiplication, and congruence. Paano naman? Sir, paano kung mag-a-add kami ng modulo? Paano gagawin? Ganito. Ayan. So, paano pa mag-a-add tayo ng modulo? Number 1, ganito lang. Let's say, we have A is congruent to B modulo M, and C is congruent to D modulo M. Sir, paano kapag i-add ko yung mga yan? Ganun rin. Number 1, pag in-add natin yan, it will become A plus C is congruent to B plus D. Pareho naman sila nakamodulo kay M. So, tandaan nyo po yan, ha? Paano naman sir kapag multiply or product? And then number 2, we have A congruent B modulo M and C congruent D modulo M. This will become AC congruent BD modulo M. Modulo M. So that is the rule or theorem in terms of addition and multiplication of congruence. Yan, ganun lang yun. Now, for more general term in this property, ito yun. Yan, so general term. So if A sub 1 is congruent to B sub 1 modulo M, for I is equal to 1, 2, up to N, then, so class, anong tawag sa notation na to? Sige nga, Math Major. Anong tawag sa notation na yan?
Summation notation.
Very good. Summation notation or sigma notation. So dito class na pumasok sa sigma notation. So paano naman, di ba kapag summation, lahat yun ina-add natin, sum na yun. So dito naman, ano yung rule in terms of summation notation? Sabi dyan, summation of A sub I from I is equal to 1 up to N is equal to summation of B sub I from I is equal to 1 up to N modulo M. So, ayan po yung rule dyan. At ito naman, ano naman yung ating symbol na yan? Ha? Ano yung symbol na yan? Anyone? Paano yan? Ano yung symbol na yan? Familiar ba kayo dyan? So, ang symbol na yan ay ito ay for product. Ito ay for sum or summation. Ito naman ay for product. Ayan, for product naman. So, sabi dyan, the product of A sub I, where I is equal to 1 up to n, is equal to product of B sub I, where I is equal to 1 up to n, modulo m. So, ngayon, anong ibig sabihin yan? For example, if 1 is congruent to negative 2 modulo 3, and 2 is congruent to negative 1 modulo 3, then, plus kung papasin, pareho sila ng modulo na 3. Nung naka-modulo 3, pareho sila. So, kung kukunin natin yung ang addition yan, yung sum yan, kunin natin yung sum. This will become negative 2 plus, 1 pala yun. So, this will become 1 plus 2 congruent to negative 2 plus negative 1 modulo 3. This will be 3 is congruent to negative 3 modulo 3. So that is our answer. So ayan. So that is 3 is congruent to negative 3 modulo 3. Nakuha na natin yung sum nila. Eh paano naman sa yung product? So lagyan natin product. So for product, this will be this will be 1 times 2 is congruent to negative 2 times negative 1 modulo 3. And this will become 2 is congruent to 2 modulo 3. Ganun lang. So, nakuha na natin yung kanilang summation notation from this two summation. Nakuha natin yung addition or sum and product nila. Ayan. So, next, for congruences. Ayan. Let's talk about these corollaries. Ayan. So, corollary 1, sabi dyan, given A, B, C is an element of Z, then A is congruent to B modulo M if and only if A plus B is congruent to B plus C modulo M. Pakitandaan po ito, mamaya gagamitin natin to. Again, if A, B, and C is an element of Z or integers, therefore, then A is congruent to B modulo M if and only if A plus C is congruent to B plus C modulo M. So kung papansin nyo, nalagdag yung C dito. Pareho sila ng value. Pareho yung term. No? Next. Corollary 2. If A is congruent to B modulo M and C congruent to D modulo M, then, number 1, AC is congruent to BC modulo M or any integer C. Kahit anong integer tong C na to, kapag minultiply mo yan, dapat magiging congruent pa din sila. So, itry nga natin. Try natin. So, halimbawa, or for example, we have 7 congruent to 2, ayan, or 7 congruent to 4, no? Modulo, 7 congruent to 3 modulo 4. Halimbawa lang na ganyan, ano? 7 is congruent to 3 modulo 4. Sabi dyan, kahit ano daw integer, for example, let's try that C is equal to 2. So, try nga natin. So, sabi AC is equal to BC. So, magiging ito ay 14 or 7 times 2 is congruent to 3 times 2 modulo 7. Tingnan kung magiging tama yung sagot. So, this will be 14. Tapos ito ay 6 modulo 7. Ayan. So, tama ba? Na yung magiging sagot natin ay 6. Wait lang. So, dito 3 times 2. So, modulo. Ayan. So, dito, ang sabi for any integer C. Ayan. So, AC is equal to BC. So, A that is 7. So, 14. And B that is 3. So, 6 modulo 7. Ayan. So, kung titignan niyo dito class, no, ang tama ba na magiging remainder daw ay 6 o ang ating magiging remainder ay 6 or negative 1? Kaya kung dito ngayon, dapat ito ay magiging, okay lang. So, 0 or 14 pala to, tapos ito dapat ay 6. Ayan, pero based on the theorem na ito ay na-presume na true. Ayan, yun dito. Ayan, ito ay na-presume na true. So next, we have number 2. If ax plus cy is congruent to bx plus dy modulo m. Ayan. So sabi dyan, ax daw plus cy is congruent to bx plus ax plus dy modulo m. Congruent daw yan. Ax plus cy, tama ba? Ax plus cy congruent to modulo m. Okay. So bago pala tayo punta sa number 1, sige mabigyan muna ako ng example. So for example pala class, we have 3 is congruent to negative 1 modulo m. Ayan. Modulo m. So ngayon, if we have 3 congruent to negative 1, modulo 4 pala, modulo 4, ayan. Then, kung gagamit tayo ng 2, ay c is equal to 2, this will become 3 times 2 is congruent to negative 1 times 2 modulo 4. Ayan, modulo 4. So this one will become, ito class ay magiging 6. Oh, sorry, this one will be 6 is congruent to negative 2 modulo 4. So tama, that is 6 is congruent to negative 2 modulo 4. So 6 plus 2. So dito kasi natin mo, congruent naman siya kasi kung gagawin natin yung m divides a minus b. Dapat divisible yan. So magiging 6 minus or magiging 6 plus 2 is 8. That is also divisible by 4. Ayan. So that is divisible by 4. So same lang sila. Napalitan siya ng numbers pero same pa rin sila na congruent. Next, number 2. We have ax plus cy is congruent to bx plus dy modulo m. Ayan, modulo m. Next, for number 3, we have a raised to k is congruent to b raised to k modulo m for any integer k. For example, we have 3 is congruent to negative 1. 3 is congruent to negative 1 modulo 4. 3 is congruent to negative 1 modulo 4. Then, if we're going to make n is equal to 2, then 3 raised to 2, ayan. 3 raised to 2 is equal to negative 1 raised to 2 modulo 4. Modulo 4. Then, ay meron pa ata ito. Ayun. Then, aabutan pala. Ayan. So then, ito ngayon, nandito na tayo sa modulo 4. So then, 3 square, ayan, is equivalent to, or is congruent to negative 1 raised to 2 modulo 4. So tama naman that 9 is congruent to 1 modulo 4. Tama naman ang magiging remainder ay 1 kapag dinivide ko yung 4 kay 9. Tama po ba? Nasusundan po ba ako third year math majors?
Opo.
Ayan. Theorems pa lang naman to, no? Next, we have number 4. A minus C is congruent to B minus D modulo M. Ayan. A minus C or A minus C is congruent to B minus D modulo M. So for example, we have 1 is congruent to 4 modulo, and 1 is congruent to 4 modulo 3. Now, if we're going to perform the equation na A minus C is congruent to B minus D modulo M, this will become negative 1, negative 2. And negative 2 is congruent to 1 modulo 3. So tama naman yan. The remainder, if we're going to divide negative 2, if we're going to divide 3 to negative 2, ang magiging remainder niyan ay 1. Ayan. So then 1 minus negative 2, pagsamahin natin, pagkasamahin lang yan, no? Then 1 minus negative 2 is congruent to 4 minus 1 and 4 minus 1 modulo 3. And that is 3 is congruent to 3 modulo 3. Therefore, na-prove ito. Okay? So pagtandaan po yung apat na theorems na yan kasi mamaya gagamitin natin yan. Mahalaga yan. So dagdagan lang natin ito. So ayan. Ayan. Okay. Ito na. Find the least residue modulo 7 of 37 times 45 plus 6 times 15 raised to 8. Again, BSED Math third year. Pag sinabi nating least residue, ano yan ulit? Remainder. Very good. Ito ay remainder. So that means, class, hinahanap natin yung remainder ng operation na to. If we're going to divide 7 to 37 times 45 plus 6 times 15 raised to 8. So alam to, class, ang gagawin nyo dyan, o sige nga, try ko, ba't pa mapapahirap, di ba? So 37 times 45 plus 6 times 15 raised to 8. Nilalabas ng malaking number, saka mo i-divide sa 7. Di ba yun ang gagawin mo dyan? Pero sobrang tedious ng computation na yon. Ngayon, anong gagawin natin? Gagamitin natin yung theorems about modulo or modular arithmetic in order to solve this one. Ayan. Ayan, in order to solve this one. So, gamitin natin. So, paano mangyayari ngayon dito? Iisa-isahin lang muna natin sila. Isa-isa. So, paano isa-isa? 37. Kapag ba kinuha ko yung 37 tas modulo 7, ano yung remainder? Kapag ba kinuha ko yung 45, modulo 7, ano yung remainder? Kapag ba kinuha ko yung 6, modulo 7, ano yung remainder? Kapag ba kinuha ko yung 15 raised to 8, modulo 7, ano yung remainder? Iisa-isahin natin sila. So, game. Unahin natin, si 37 is congruent to ano kaya ang magiging remainder? Modulo 7. Anyone, BSED Math third year, what will be the remainder if we're going to divide 7 to 37?
2 po.
2 po.
The answer is 2. Very good. Yeah. The answer is 2. Therefore, we'll have 37 is congruent to 2 modulo 7. Next, punta naman tayo kay 45. So, 45 is congruent to ano kaya ang remainder modulo 7. What will be the remainder?
3 po.
The remainder will become 3. Very good. Ayan. So next. So ngayon, class, meron tayong dalawa. Ngayon, ano ba yung sabi kanina? Then, by using the theorem that we have discussed earlier, it says na pwede natin itong i-multiply. Tama ba? Kasi pareho naman sila ng modulo 7 eh. Nagigets mo ba ako? Yes, Math third year. So pag samahin natin sila, let's combine them using multiplication. Therefore, this will become 37 times 45 is congruent to 6 modulo 7. Nasusundan po ba ako ng taong bayan? BSED Math third year?
Opo, sir.
Opo.
Ayan. So ang lumalabas ngayon na ang remainder nito, kapag pinag-multiply natin yung 37 times 45 at dinivide mo yung kay 7, ang lumalabas na remainder ay ano?
6 po.
6.
Very good. So next, let's move on to the next one. Dito naman tayo kay 6 times 15. No? 6 times 15 raised to 8. So unahin natin si 6 is congruent to ano kaya yung magiging remainder kung pag-divide natin yung 6 by 7. Ano yung magiging remainder? Anyone? Oh, natahimik kayo, no? Ano yung kaya magiging remainder? Sige nga. 6 divided by 7. Oh. Any idea?
Negative 1 po.
Very good. Napakagaling naman, Christina. So ito po ay negative 1. Tama. Negative 1 ang magiging. Sir, pwede ba yun? Yes, pwede. Halimbawa, dinivide ko yung 2 divided by 3. Negative 1 ang remainder nun. Tama po ba? Nasusundan ako? So, sir, pwede pa rin negative na remainder? Yes, pwede yung negative na remainder. Okay na tayo kay 6. So, sino lang ang natitira? 15 raised to 8. Eto, mapapalaban ka dito. Kay 15 raised to 8. How are we going to determine the remainder for 15 raised to 8? Paano gagawin natin? Ganito lang. Unahin mo, si 15 lang muna, yung base lang. So if we're going to find for the remainder, also 15 is congruent to blank modulo 7. What will be the remainder if we're going to divide 7 by 15?
1 po.
15. Ito ay
1.
positive 1. Tama. So this will become 15 is congruent to 1 modulo 7. Eh paano naman ngayon kapag 15 raised to 8? So kung titingnan natin class, based on our corollary, no, nakikita-discuss kanina na 1.5, yung ating number 3 kanina, ang sabi nung kanina ay A raised to K is equal to B raised to K modulo M for any integer K. So dito, pareho naman sila, di ba? So we can say that 15 raised to 8 is equal or is congruent also to 1 modulo 7. Ayan. So pareho din sila ng kanilang remainder. Kasi nga, based on the corollary number 3 kanina, A raised to K is congruent to B raised to K modulo M. So pareho naman sila ng base, pareho naman sila ng modulo. Ang pagkakaiba lang, ito ay 15 times 15 times 15. Kung ang remainder nito ay 1, therefore ito rin ay magiging 1. Nagigets po ba ako ng taong bayan? BSED Math 3rd year?
Opo.
So ngayon, anong gagawin natin? Sir, may mga ganyan-ganyan na tayo. At then pagsama-samahin natin. Pagsama-samahin lang natin. So pag pinagsama-sama natin yan, ito yung isa kanina, no? So pag pinagsama-sama natin yan, i-combine lang natin yan, this will become 37 times 45 plus 6 times 15 raised to 8 is equal to, ano yung is congruent, no? Is congruent. Ano yung remainder dito? Ano yung remainder? 6 is congruent to 6. Di ba? Is congruent to 6. Eh di ba dito class, no? Kung ito multiplication to, so ibig sabihin ang remainder nitong 6 ay negative 1. Ang remainder nitong 15 raised to 8 ay positive 1. Eh di ba multiplication ng operation? So kapag pinag-multiply ko yung kanilang remainder, ano magiging sagot? Negative 1. So magiging 6 plus negative 1, and that will be equal to ano?
5 po.
5 modulo 7. So ang pinakasagot natin dito class ay 37 times 45 plus 6 times 15 raised to 8 is congruent to 5 modulo 7. This will be, this will be our answer. Nagets po ba ako? BSED Math 3rd year? Math majors? Nagets ako sa modulo na to?
Opo, sir.
Galing ganun lang. So next. And I think this will be our second to the last example at tayo ay makakapagpahinga na pare-pareho. Yes, 2 hours lang tayo. Oh. Kita mo, bawi na lang ako sa Biyernes. Ayan. So example number 1, okay na tayo dyan. Example number 2, find the unit digit. Pag sinabing unit digit, ito yung huling digit sa number. So halimbawa, ano ba ibig sabihin ng 3 raised to 103 na yan? 3 times 3 times 3 times 3, o gantuhin ko na lang. Ang ibig sabihin ng 3 raised to 103 na yan ay 3 times 3 times 3 times 3 up to 100 times mo, ay 103 times mo i-multiply yan sa isa't isa. Nagets po ba? Tama ba? Ganyan? Okay. At ito naman, 2 raised to 78. 78 times mo i-multiply yan. So ngayon, paano mo malalaman yung huling number niyan? At ilagay mo sa calculator, sabi nila. Kung pag nilagay mo sa calculator yan, hindi kaya na calculator. Sige nga po, try nyo nga po kung may calculator kayo. Pakitry nga po yung 3 raised to 103. Tingnan nyo kung kaya na calculator. Ayaw, di ba? Ang lumalabas ay error na. Di ba error na yung lumalabas? Try ko rin, baka mapahiya ako. 3 raised to 100. O, di ba ayaw na? Sobrang dami ng number. Tama ba? Nag-error na. Eh, problema, ang hinahanap natin yung huling number o huling digit. How are we going to determine the unit digit given this 3 raised to 103. So dito, meron tayong mga methods dito. Actually, marami kang meron sa pwedeng isolve dyan. Pwede mong gumamit sa kay Fermat Rule or Fermat Theorem. Pwede ka ng Chinese Remainder Theorem. Pwede rin naman yung bilang-bilang lang at pwede rin naman si modulo. Since modulo ang topic natin, gagamit tayo ng modulo in order to solve this example. So, paano namin siya gagawin? No? Pagdating kay unit digit, always remember, no, the technique of the congruence is to create a power that will lead to the value of either 1 or negative 1. So, dapat gagawa ka lang doon ng power na mag-lead sa atin kay 1 or negative 1 in modulo 10. Modulo 10 lagi ang ginagamit kapag unit digit na pinag-uusapan. Ngayon, sir, paano yun? Ganito. Siyempre, hanapin mo dyan ngayon dito, no? Sa 3 times 3 times yun na yan, saan kayang part or ano yung exponent ni 3? Ano yung magiging exponent ni 3 na kung saan ang magiging remainder natin ay 1 or negative 1? Anyone? Given that modulo 10 to, modulo 10. Modulo 10. So, ano kaya exponent? So, ang magiging exponent nun ay 4. Kapag 3 raised to 4 is 3 times 3, 9. Times 3, 27. Times 3, 81. 81, modulo 10. Okay, pwede yun, no? Magiging ang remainder nun ay 1. Paano kapag negative 1? Since we're talking about remainder, yung least residue, pinakamababa. Paano pag negative 1? Ano kaya pwede natin gamitin? 3 raised to? Ano? Ito lang yan. Tandaan nyo na kapag negative 1 kapag negative 1 ang remainder, kung modulo 10 yan, dapat ang lalabas na value mo ay 9. Nagigets ako? Kung modulo 11 yan, dapat ang lalabas na value mo ay 10 para maging negative 1 ang remainder. Gets po ba ako? Third year?
Opo.
So given this 3 as a base, ano kaya dapat na exponent ni 3 para maging negative 1? Square, very good. So 3 square is equal to 9, and given that our modulo is 10, therefore our least residue is negative 1. Nagets po ba ako? Third year? Ha? Nagets po ba ako? Ha? Nagets ba ako? BSED Math third year, baka yung iba dyan natutulog na. Nagets ba ako, Mark Joseph?
Nalilito. Sir, paano po nakuha ulit yung negative 1 na yon?
Ayan, yung negative 1. So sabi ko nga kanina, no, ibabase mo yan kung saan ang modulo natin. Ang modulo na ginagamit ngayon ay 10. So always remember, halimbawa, syempre kung 1 ang gusto mong remainder, so dapat yan ay maging 31 ganon. Kung modulo 10 yan, 31. Kasi pag 31 divided by 10, ang remainder ay 1. Tama ba?
Okay po, sir.
O ngayon naman, kung gusto ko naman kunin ay negative 1, kung ang modulo mo ay 10, dapat ang lalabasan lang yan ay 9. Kasi 9 divided by 10, baliktad. So,
1 remainder.
9 divided by 10, ang magiging sagot niyan ay negative 1 yung remainder. Gets po ba? Ako pabaligtad lang tayo. Ayan. So ngayon, anong gagawin dyan? Since we already know that in our 3 raised to 2, ang answer, ang remainder natin ay negative 1, anong gagawin natin? Yan yung gagamitin natin basehan. Yan yung magiging basis natin. So this will become 3 raised to 2, 3 squared. So that is 9, no? 3 squared, that is 9. Ngayon, ano gagawin dyan? Ano ba yung exponent? 103. Tama po ba 103 yung exponent?
Opo.
So ngayon, ang nandito ngayon ay 3 raised to 2. Ano kaya yung ilalagay kong exponent kay 3 raised to 2 na kung saan ang magiging sagot ay 103? Para may 102 lang. 102 yung magiging exponent. So ito, pwede ko ito lagyan ng 3 raised to 2 raised to 51. Wag malito ha. Class, loss of exponent to. Loss of exponent. We have x squared raised to 4. Pag ganyan, ano sagot nyo?
X raised to 6. Ay, 8 pala.
X raised to, ala ko 6, x raised to 8. Tama ba? Kasi kapag yung exponent ay naka-exponent pa ng isa, minumultiply natin yung exponent. Tama po ba?
Apo.
Kung ano yung ginawa mo dito, ganun din dito. Ang problema lang, sir, 103 to eh. Kalmahan mo, mamaya ka. Hindi nga kasi tayo pwede, since nga ito ay 2 eh, hindi tayo pwede na kahit anong i-multiply 52, pag ginawa natin 52 to, sobra naman, 104 yun. 103 ang kailangan natin. Nagigets po ba ako?
Apo.
So magtitira tayo ng isang 3, mamaya yon. So dito, 3 squared raised to
Sir,
51.
pwede 3 raised to 30 po.
3 raised to
34.
34. So that is 3 raised to 34.
102.
Itong 1 ba? 3 raised to 3 ba? 3 raised to 3? Ha? Ganyan, tas 3 raised to 34. Tama ba ganyan?
Opo.
Ayan. Oo, pwede to. So, kaya lang, ang pinagbabasihan niya kasi natin ngayon, itong nasa unahan na to. Ayan. Ito yung pinagbabasihan natin, that is 3 raised to 2 is equal to 9. At alam natin, dito kasi sa 3 raised to, alam natin na agad na ang remainder ay negative 1. Tama po ba? Ayan, kaya gagamitin natin ngayon, 3 raised to 2, para tayo mahirapan, raised to 51. So, ngayon, is congruent to, again, ano ulit yung remainder ng 3 raised to 2?
Negative 1, sir.
Negative 1. And based on our theorem earlier, ang sabi, A raised to K is congruent to B raised to K modulo M. Pareho naman naka-modulo 10 yan. So ito, i-raise mo rin ito kay 51. Gets ako? Nagets po ba ako? BSED Math, third year? Ha? O, ngayon, anong gagawin natin ngayon? O samahin mo, 3 square raised to 51, that is 3 raised to 102, is congruent to what is negative 1 raised to 51?
Negative 1 po.
O, di negative 1. O, diba? So, our answer is negative 1. Kaya lang, 102 lang ito, di ba? Di ba 102 lang yan? So, may nawawala pang isang 3. Tama po ba? Nagigets po ba ako? So, anong gagawin natin ngayon? I-multiply mo itong ngayon pa sa isang 3. Gets ako? BSED Math third year. Nagets po ba ako? Then, ang lalabas dito ngayon ay 3 raised to 103 is congruent to negative 3 modulo 10. Gets ako? BSED Math third year? Oh, go. Ito, bali yung 3 raised to, okay, pwede lang din naman. Pwede rin naman. So, ano ba sasabi mo? Ito, lalagyan ko pa ng times 3 dito, ganun. Ito. Okay. Okay, sige. Ayos lang sa akin. Pero dito, nilagay ko kasi, baka kasi malito. Minsan kasi, nakakaligtaan natin. Na, ay, nako, ba't may kulang pala ako ng negative 3, akala ko negative 1 yung sagot. Ayan. So, pinakita ko lang dito. Pero ayos lang sa akin, go lang. So now, we have 3 raised to 103 is congruent to negative 3 modulo 10. Ito na ba yung sagot natin? Siyempre, hindi pa. No? Since ang hinahanap natin kasi ay positive na unit digit, ala namang negative na unit digit, di ba? We're talking about unit digit. Ala nga naman, sir, naging value yan ay 1,000, halimbawa, ang value kasi yan ay 1,260 negative 2. Pwede ba yung ganyan? Yung unit digit mo ay negative? Di ba hindi naman? Tama ba? Again, class, ang hinahanap natin ay unit digit. Pag unit digit, yung last digit ng number. So there's, wala siyang possibility na maging negative yung unit digit. Gets po ba ako? Lagi siyang positive. Nagigets ako? BSED Math third year? Ha? Nagigets po ba ako? Oh. Nagigets ba ako? Math major? No? Wala tayong unit digit na negative, syempre. Meron tayong negative na number, pero wala tayong negative na unit digit. Halimbawa, negative 1,256. Pwede yan. Pero hindi mo pwede sabihin na, sir, positive 1,250, kaya lang yung 6 ko ay negative. Hindi pwede yan, di ba? Unit digit ang pinag-uusapan. So, laging positive ang magiging sagot mo dito. Kaya lang, sir, paano yan? We have 3 raised to 103. Ang sabi nyo is congruent to negative 3 modulo 10. Anong gagawin natin? We will change negative 3 into positive using modulo 10. Ano kaya ang magiging remainder? O ano kaya ang magiging sagot dito? Yung ating R, kung gagawin siyang positive. Anyone? Naka-modulo 10 tayo. Modulo 10. Anyone? Ano magiging sagot dito? O tandaan nyo, parang orasan lang yan, iikot lang yan, iikot. So halimbawa, naka negative 3 ka ngayon, iikot ka ng 10 hakbang. Negative 3, negative 2, negative 1, 0. Ilan na yun? Ibilangin mo 10 dapat ha. So from negative 3, iikot lang, naka-modulo 10 yan, iikot tayo. So from negative 3, magiging negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7. So ang magiging sagot ngayon ay 7. So, ang ibig sabihin niyan, ano yung unit digit? The unit digit of 3 raised to 103 is 7. O, nagets niyo ako? BSED Math third year? Third year. Math major. Nagets niyo ako dito?
Sir, bali ipa-plus lang po kung ano po yung value ng modulo.
Pwede. Pwede. Kasi nga, ang nakacycle tayo, umiikot lang tayo. Sundan niyo ako, kagaya na ginawa natin kanina, from negative 3, hahakbang lang tayo ng 10. Kasi parang orasan lang yan. Nagets po ba ako, Math Major?
Opo.
Talaga? How about the others? Nagets po ba ako, Angel? Nagets mo ako, Angel?
Yes po, sir.
Ayan. Pero alam nyo, meron pa ditong shortcut na malaman. Pero syempre sa exam, since modulo ang topic natin, modulo ang ipapakita nyo sa akin. Pero kung gusto nyo check-in or para ma-sure mo na tama ang sagot mo, meron tayong madaling paraan. Ganito. Papabuya ako ba naman pag-ganito lang. So, ganito. Gawa tayo ng madaling paraan. So, ito for the purpose of checking lang pero hindi ito pwede gamitin sa exam. Hindi pwede ito isagot sa exam. Since ang hinahanap mo ay unit digit at modulo 10, ganito lang. Try mo. Di ba kapag, kapag nag-try ka ng 3, syempre ang huling number niyan ay 3. Kapag tinry mo naman 3 times 3 or 3 square, ano yung huling digit mo?
9 po.
9. Kapag 3 raised to 3, ano yung unit digit mo? Ano yung unit digit? 7. Kapag 3 raised to 4, ano yung unit digit? Unit digit lang pinag-uusapan na wala ko pakialam kung gaano kalaki pag-uusapan. Yung dulo
One.
number.
1 po.
1. O pag 3 raised to 5, ano yung unit digit mo? Ano?
3 po.
Ano? 3. Paano pag 3 raised to 6, ano yung unit digit mo?
9 po.
Ano mapapansin nyo?
Umiikot lang po.
O, di ba? Umiikot lang sila. So, umiikot sila every, eto lang ang kailangan mo dyan, 4th term. Pagdating ng 5th term, iikot na siya. Tama po ba? Nagigets ako, BSED Math third year?
Opo.
So, ibig sabihin, kahit milyon-milyon pa yung ating exponent, basta iikot lang yan ng 4, naka-modulo 4 lang yan. Eh ano ba yung exponent? 103. Nagigets mo ba ako? 103. So, kung 103 yan, ilan yung ikutan? 4. I-divide mo lang yung 103 divided by 4. Ano magiging sagot? 100 divided by 4. Tapos
25
20.
remainder po.
27. So 27 remainder, ano yung sobra? Remainder? Ano? Remainder 2 ba? Ay, remainder 3, tama ba? 27 remainder
25 remainder 3.
5 po.
Ano ulit? Sorry, 103 divided by 4.
25 daw.
Sorry, 25. Okay, tama.
25.
25 remainder 3. Tama ba?
Opo.
Tama po ba? So ngayon, ano ibig sabihin yan? Ibig sabihin niyang class, mula dito, iikot lang yan. 25 na ikot yan. 25 na ikot. So, 1 na ikot, ayan. Balik ulit dito. 2 na ikot, balik ulit doon sa taas. 3 na ikot, balik ulit doon. So, 25 times na babalik-balik dito. Nagigets niya ako? Nagigets niyo po ba ako? So, ito na yung pang 25 na ikot. Kaya lang, may pasobrang 3. So, babalik ka dito. 1, 2, 3. Ito yung remainder. 7. Pareho ba? The remainder is 7. The remainder is 7. Nagets niyo ako? Sa shortcut?
Sir, parang mas madali yan.
Siyempre. Pero, again, this is the purpose of checking lang. Sa exam, ipapakita niyo sa akin si modulo. Ayoko nito. Pero for checking lang, at least, alam mo na, bakit parang ang sagot ko dito ay 3. Eh, chinek ko dito, 7 ang sagot ko. May mali akong ginagawa dito. O, di ba? Pero kayo, at least ito, alam niyo na tama ang magiging sagot niyo. Nagets niyo ako? Third year?
Opo.
O, di ba? Galing, no? Galing ng galing ng math, no? O, konti na lang, konti na lang. O, next, letter B. Ay, sorry lang. Letter B. O, burahin ko na to, ha. So, for our letter B, we have 2 raised to 78. Ganun lang din gagawin mo dyan. 2 raised to 78 naman. Letter B tayo. So, for letter B, dito ko na isusulat. So, anong gagamitin natin kay letter B? So, again, kailangan mag-arrive tayo sa pinakamalapit sa modulo 10. No? Pinakamalapit sa modulo 10. So, ano yon? Kung meron tayong 2 raised to 78. So, dito kasi class, pag tinry mo, no? 2 times 2, 4. Ang remainder nun ay 6 kung modulo 10. 2 times 2 times 2, or 2 raised to 3, 8. Ang remainder nun ay 2 kapag modulo 10. 2 raised to 4 ay 16. Ang remainder nun ay 6 kapag kay modulo 10. So, kung papansin naman, umuulit na yung remainder. Nasaan yung may pinakamaliit na remainder? Na kay 2 raised to 3. That is 8. At ang remainder mo nun ay negative 2. Ayan. Ang remainder mo nun ay negative 2 kapag 2 raised to 8. Naka-modulo 10 to, ano? Laging modulo 10 yan. Ayan. Ang remainder mo nun ay negative 2. So ngayon, anong gagawin natin? So now, we know that if the 2 raised to 3, no, the remainder is negative 2. Alam natin na gano'n. Ngayon, ito yung pagbabasihan natin. Kagaya na ginawa natin dito, this will become quantity 2 raised to 3. Ano yung kailangan kong exponent para maging 78 yan? Anyone? Ano yung exponent ko dapat dito?
26.
26. Sakto ba yon 78? Sakto?
Opo.
Opo.
O, sakto. So, 2 raised to 3 is raised to 26 is congruent to, ano yung exponent ulit? Ha? Ano yung exponent? Ay, ano yung remainder?
Negative 2 po.
Negative. Ayan. So, ito ngayon ay magiging negative 2 raised to, sorry, wait lang. Kung ito pala ay, okay. So, dito pala ay 15, ay 2 raised to 3, 8. Okay. So, masyado pa itong mataas. So, dito, mag-start muna tayo kay 2 raised to 5. Ayan, kay 2 raised to 5 muna. Masyado mataas kasi. So, 2 raised to 5. Tapos, ang gagawin natin ngayon, this will become negative 2 raised to 5. Ayan, negative 2 raised to 5. And that is equal to, ano sagot dyan? Negative 2 raised to 5.
Negative 32.
Negative 32. What is the remainder? Negative 2 pa din. Tama po ba? So, ibig sabihin ng class, we can say that 2 raised to 15, ang remainder nun ay negative 2. Tama po ba? Tama ba ako doon? BSED Math third year? Ha? So, ngayon, punta tayo ngayon. Unti-unti natin. So, now, gamitin naman ang basis ng 2 raised to 15. As we all know that the remainder is negative 2. So, 2 raised to 15, ano yung nilalagay kong remainder para maging 75 na siya? Ay, para lumapit sa 78. So, ang gagamitin mo ng exponent pala ay 5. Kasi 15 times 5 is 75. Tama po ba? Nagigets ako? Ha? Third year? So 2 raised to 15 raised to 5, 2 raised to 15 raised to 5, ayan. So is equal to, ano may sagot dito? Negative 2 raised to 5 ulit. Tama ba? Raised to 5 ulit. At ano ulit yung remainder kapag negative 2 raised to 5? Ano ulit yung remainder?
Negative 2.
Negative 2. O, di ba? So, ang magiging remainder yun ay negative 2 pa din. So, nakailan na tayo? 2 raised to 75 is congruent to negative 2 na. Ang ating remainder ay negative 2 modulo 10. Kaya lang, tapos na ba to? Tapos na ba yan? Ha?
Hindi pa
Ito na ba yung sagot?
Po.
Hindi pa. Bakit? May kulang pa. Tama ba? Ano pa yung kulang? 3 2 pa. So, ibig sabihin, kailangan ngayon para maging 2 raised to 78 yan, i-multiply mo pa to kay 8. Tama ba? Tama po ba? Kasi 2 times 2 times 2 pa ang kulang. So, 8. Therefore, it will become 2 raised to 78 is congruent to, ano sagot? Ano yung sagot? Negative?
Negative
16. Tama ba? Negative 16. Eh kaya lang, naka-modulo 10 tayo. Pag minodulo 10 ko itong negative 16, ano yung magiging remainder? Ano yung magiging tira?
Negative 6 po.
Negative 6. Again, unit digit ang hinahanap, kaya bawal ang negative. Kapag tinransform ko to into positive, ano magiging
4 po.
ano may sagot? Magiging 2 raised to 78 is congruent to ano? 4 modulo 10. Tapos, ganun lang yun. Question, BSED Math third year. Math major course. Question? Nagets ba ako, Math major?
Opo.
Opo.
Mahirap ba yan? Modulo-modulo? Mahirap ba? Di ba madali lang? Ha? Mahirap ba?
Opo.
Ano mahirap? Madali lang yan. Kayang-kaya niyan. O next. Ayan, parang nabinigay ako sa inyo. Ano. Ito promise class na. Number 3. Find the remainder ang hinahanap, when 4 raised to 220 is divided by 65. O, di ba? Medyo mahirap to ngayon. Magpo-4 ka ng 4 times 4 times 4 ng 220 times, tapos i-divide mo pa sa 65. Tinatanong kung ano remainder nun. Ganito lang din yan. First thing that we need to do is to find for the nearest power to 65. Ano ba yung nearest power sa 65? Given that the base is 4. Ayan. So, ang dinivide sa 65. So, ano ba yung nearest power sa 65 given that the base is 4? Ito ay 4 raised to 3. Tama po ba? Kasi 4 raised to 3 is 64. Kung ang modulo natin ay 65, ano yung magiging remainder?
Negative 1.
Very good. So 64 is congruent to negative 1 modulo 65. Tama po ba? Nasusundan ako? Ayan. So since we already know that the remainder in 4 raised to 3 is negative 1, this will serve as our basis for another exponent. So this will become 4 raised to 3. Alam mo, ang exponent ay negative 1 raised to 220 yan. Kaya ang lalagyan natin dito ay 73. Kasi 3 times 3 times 73 is 219. Tama ba? 219?
Opo.
So may kulang tayo ng isa. I-reserve mo yung isa na yung mamaya, no? So ngayon, it's congruent to negative 1 raised to 73 modulo 65. Game. So lagay mo dito 4 raised to 219 is congruent to what is negative 1 raised to 7. Sir, bakit ganun? Bakit kanina binukod-bukod mo pa? Kasi po, masyadong mataas ang magiging sagot natin kapag binanatan natin ng negative 2 raised to 78 agad. Masyadong mataas yon. Pero kapag negative 1 lang yan, or 1, pwede nang irekta kasi madali naman yung sagutan. So what is negative 1 raised to 73?
Negative 1.
Negative 1.
Negative 1 modulo 65. Ito na ba yung sagot?
Hindi pa po.
Pa po.
Multiply pa natin sa isang 4. Kaya magiging 4 raised to 220 is congruent to negative 4
Negative 4.
modulo
65.
65. Ayan. Negative 4 modulo 65. Ngayon, again, ang kailangan natin ay positive na sagot. Kung gagawin ko tong positive, yung negative 4, ano yung magiging sagot natin?
6 po.
61 po.
Magiging sagot ay 61. Kasi ang modulo natin ay 65 na yun. Ayan. So, 4 raised to 220 is congruent to 61 modulo 65. Therefore, the remainder is 61. Question. BSED Math, third year, Math Major. Question. Clarifications? Wala po bang tanong? Ha?
Wala naman po.
O, parang Diyos ko naman, oh. Walang tanong. O, di ba? Sabi ko, mabayos lang tayo. 2, 4 to 6 pa lang, oh. O, di ba? Galing. Ayan. Walang tanong? Qualifications? Violent reaction? Ha? Wala po ba tanong?
Wala po.
Okay. Again, some announcements. On Friday, we'll have a class at 3 to 6 p.m. Saturday, 3 to 6 p.m. Then, wala tayong klase next week. Tapos, after Holy Week, we will have our midterm examination. Examination Saturday, 3 to 6 p.m. Ayun. Questions? Clarifications daw? Wala po ba? Wala tanong? Wala tanong? O baka may concerns pa kayo? Wala? Okay. Ano wala? Airham. May concerns ka, Airham? O bakit? Ayaw nyo ng Saturday class? Okay na yun. Kaya na natin yun. Bakit?
Meron po kaming subject ng morning saka afternoon.
Kayang-kaya nyo yun, kayo naman. Pero don't worry, madali lang naman ang lesson. Ang lesson lang naman sa Saturday, functions lang naman. One-to-one function, on-to function, tsaka symmetries. Natin yung madali yun. Madali lang yun. So, para marami kong itatanong sa midterm, di ba? Ayos. Eh, kaysa gusto nyo puro mathematical induction sa midterm. Oh, wala akong bibigay na ano no, na ABCD, puro mathematical induction lang. Ano, may dulo. Kayang-kaya nyo yun, kayo pa ba? Sulitin niyo, ano na yun na, sulitin niyo, saglit na lang naman. Palahati na lang naman. Ayan. Kung walang question, walang concern, sige, let's call it a day, class. See you on Friday. Ayan, magpakatalino at magtiyaga. Bye-bye!
Thank you.